Aeroflow Performance and Bosch Motorsport have collaborated to provide a range of precision EFI components to suit your project. Hey guys, Pat from Aeroflow, and as you may know by now, we've been selling some Bosch injectors as part of our catalogue range. Lately, they've been hugely popular from the 495cc all the way through to the Firehose 2200cc's for all of your fuel demands. The injectors have been such a popular addition to our range that we've decided to expand that range with Bosch, and we're happy to be on board with them and be providing some more products that we'll talk about now, and we also have a range of accessories that will complement those Bosch products. So as I mentioned, we've got the injectors, obviously all of the fuel rails that we have in the range complement those, fittings and electrical connectors, that's already there. Some of the new additions that we've got with the Bosch products are the drive-by-wire throttle bodies. Now these are available in our range in the 74mm and 82mm. Throttle body from Bosch. These units are actually used in quite a lot of high-end supercars, a lot of OEM fitments, so the quality is right up there. The response and the actuation of the motors is one of the highest options that's out there, and that's why we've decided to utilize these within the range to fill a gap for 4 and 6-cylinder engines, where we've already got our 102mm fly-by-wire throttle body. That basically covers most of the V8 applications, or other V8s already have maybe a fly-by-wire throttle that can suit most of their needs as a factory unit. But we've brought these on. They're working great on popular 6-cylinders like 2Js or RBs that have got aftermarket engine management that'll control the fly-by-wire throttle, and then the smaller unit would be for a smaller capacity, so something like a 2-litre or 1.6 litre 4-cylinder. So that's basically covered the whole range within. Why would you use a drive-by-wire throttle body? Well, there's a few different things. So now with the relative ease and access for aftermarket ECUs or power control modules, you can command a drive-by-wire throttle body quite easily, and that's useful because it removes a lot of the finicky adjustments or additional weight even, or components required with a traditional mechanical throttle body. While a cable operated throttle body is a very simple unit, in theory, the problem that you'll find is the cable can need adjustment after time in the car or different heat cycles and things like that. You've got to go back and you've got to adjust the cable. They often need a separate idle air control valve to manage idle when the throttle blade is closed, and then they have a little valve that sort of moves in and out and opens the throttle to manage idle. These can be a little bit difficult when you've got an aftermarket sort of system, or like say a large cam with low vacuum, or some sort of addition like forced induction. The manual throttle body can be a little bit of a pain for a street car. The electronic throttle body does away with the need for any throttle position sensor or idle air control valve, because it's all maintained by this electronic motor that's on the side, and that's tuned up by either the factory ECU, which is already running a electronic throttle body, or an aftermarket ECU or PCM that is capable of running that. So you can spec in when there's any particular load or a vacuum drop or increase. The blade can be opened or closed quite easily with the motor. There's nothing else that needs to be interacting with the airflow through to the intake manifold. You've also got multiple benefits in the case of traction control or torque management. So the driver or the owner can have their foot flat to the floor. While using wheel speed sensors, you can also command the throttle body to actually close. So the rest of the engine is still running as if it's full throttle, but you can actually open and close this to manage the torque that's being produced by the motor. So that's another real benefit, especially popular with tuners using aftermarket ECUs. So they're the two options that we have with the drive-by-wire throttle bodies. We also have the plug and pin accessories to suit both of these. So we can add the plug, so you can splice that into your loom, or if you're making a loom from scratch, that's where you'll get that adapter. We also have these weld-on flanges. So if you're making your own throttle, you're making your own intake manifold or plenum, or modifying an existing one, you can use this weld-on flange that will be you can fit it to the existing manifold or the one that you're making. When it comes to forced induction, you may also find that you'll need a high pressure clamp. So like these billet clamps that basically has been extremely popular in high boost applications. That'll basically clamp on the end there. This little adapter flange will bolt straight onto the Bosch throttle body. So then you don't have to worry about welding a flange onto the Bosch throttle body. It's always a little bit risky, especially if you're not a very, very high quality welder, to weld onto an electronic throttle body. It can mess with the electronic component in the motor there. So this flange removes the need for you to have a welder, so you can DIY it, and it also reduces the risk of damaging that nice new electronic throttle body that you've got. So these are a couple of accessories that we've already got in our range. Now, when you go to a electronic throttle body, you're going to need, as I mentioned earlier, a PCM, a power commanding module, or an ECU, a electronic control unit, to be able to manage that. For that PCM or ECU to have an input, you're going to need a pedal that can talk to that ECU. So this is another one from Bosch that we've introduced to the range. This is their drive-by-wire pedal. It is designed to mount on a firewall, so you can mount it wherever you need. There's 16 degrees of actuation in this pedal, which is roughly about 70 mil worth of travel. So still a reasonable amount of travel there. Some people early on with the with electronic throttle bodies, definitely in OEM applications, found that the response, but also the feedback and the way that they can feed the throttle in when they're driving, particularly on a circuit application or a street car, was maybe a bit laggy, or there wasn't enough play in the throttle pedals that were available at the time. So we've managed to overcome this by using this particular product from Bosch. There's plenty of actuation. I know it doesn't look like a lot when it's just in isolation, but when that's mounted down on the firewall and you're using just perhaps your big toe or your foot to actuate it, there is quite a bit of throw there. These throttle bodies as well, if we just touch on that response thing, the throttle body, the time from full close to full open or full throttle position on these late model throttle bodies is anywhere from 30 to 80 milliseconds. So it's a really small, blink of an eye and it's wide open. So that's something that you don't have to worry about with these later Bosch designs. So that's quite a good point. Again, with the pedal, you've got the plug and pin that's available that can be pinned in and suited to your application and your loom, however it is that you're going to go about it. Moving on from the throttle bodies and the pedals, we've also added a new sensor from Bosch, which I say new to us, but it has been around for a little while, from Bosch Motorsport. This little transducer, or temperature and pressure sensor, combines those two things. So often when we're talking about any electronically managed engine from an OEM or an aftermarket ECU, you'll have sensors or transducers to monitor pressures and temperatures within or around the engine. So say an intake air temperature or a coolant temperature sensor, and then perhaps a pressure sensor, which will be for an oil pressure, so say a transmission or an engine oil pressure. You'll have these separate sensors. When it comes to an aftermarket ECU, you may have a certain amount of outputs or inputs that will feed information to the ECU. The more sensors you have, the more of those inputs you're going to use up. Now, when it comes down to a very complex system that's perhaps got an automatic transmission control, forced induction, traction control, wheel speed sensors, all of those things, every little input counts. So rather than adding on boxes and boxes to expand the ECU's capability, this little sensor can actually read the temperature and pressure in either air or fluid. So you've got a 150 PSI range for pressure. So that will cover most automotive applications in oil pressure. And also coolant temperature and pressure, which is important in a forced induction application. It gives you a bit of a heads up if perhaps a head gasket's leaking or something, and that combustion pressure is getting into the system. In addition to the pressure that it can read, the temperature rating of this sensor is from 0, or actually it's -40, I think. So -40, which will give you a reading on your cold starts and things like that, all the way through to 140 degrees Celsius. So you've got that large range, that 180 degree range. So you'll be able to use that for, again, almost any automotive application where you need to monitor temperature. In some cases, you might find that a very high level automatic transmission might peak a little bit higher than that, but anytime you're going over 150 PSI or 140 degrees, you've probably got a problem in most applications that you'll find on the street or at the racetrack. So that's a really handy sensor. The only odd thing about this sensor is the thread, whereas most sensors that you'll find will be a 1/8 NPT thread, which is a tapered thread. So your traditional transducers for temperature or pressure will have a 1/8 NPT thread. To overcome that, to match the M10x1 thread on this, we've developed this little adapter, which has the 1/8 NPT thread on the input side, where you fit that to a cylinder head or a manifold, wherever it may be, and then it's got the M10x1 on the other end. So now you've got a really easy way to upgrade an existing sensor or an existing port that's on your motor that's already a 1/8 NPT. That'll bolt straight in there. And then of course, like all of the other components, we've got the plug and the pins available as a separate accessory so that you can also upgrade your loom and your wiring to match that sensor. So they're all available from aeroflowperformance.com. One last thing that we've also added from the Bosch Motorsport catalogue is map sensors. So this one here is a GM LS3 style map sensor. Now these are very popular as an upgrade, especially with LS motors that are going from naturally aspirated to a boosted application, whether it's supercharged or turbocharged. You need the map sensors to be able to read a little more positive manifold pressure. So when you've got a map sensor, you have to consider that the total number is split into a vacuum reading, so negative manifold pressure and positive manifold pressure. So for example, if you have a 2-bar map sensor, 1 bar, or which is roughly 14 PSI, you're looking at 1 bar of that will be for vacuum, so when the throttle is closed, for example, and then the other side of the map will read positive. So you may find that a 2-bar map sensor will only read to 14 PSI positive. Now, if that's a boosted application, you're going to run out of that real quick because it's very, very common that you'll see well north of 15, 20, 25 PSI. So these little LS3 units are a 2.7 bar map sensor, and they will actually read up to 28 PSI positive manifold pressure. So still, of course, the same 14.7 on the vacuum, and then 28 PSI on the top end. So this is a very popular unit for a lot of LS applications, and it can, of course, be used for any application where you need to upgrade a map sensor that has a little bit more scope in it, a little bit more range. It's a very high quality unit, so the resolution of these map sensors is very good. You find that it's very consistent reading across all types of intake temperatures. So obviously in a boosted application, as the temperature gets higher, this can allow for that variation in pressure due to temperature. So it's still a very accurate reading map sensor, and that's why we've added that to our range. Now, I don't have one of these right here at the moment, but we do also have a direct fit 2.5 map sensor for a Falcon engine, the 6-cylinder Ford motor, otherwise known as the Barra. for BABF, for example. So if you're taking a naturally aspirated Barrett engine, which is very common these days, there's a lot of them out there, and then you're going to add a turbo, you'll need to upgrade that map sensor. Now, the map sensor that we have for the Barras is actually the one that's mounted in the intake manifold, not the one that's on the inlet piping that you might be familiar with if you're familiar with a turbocharged or a factory turbocharged Barra. The 2.5 bar map sensor for the Barras will read up to 22 psi of positive manifold pressure. So again, for most NA2 turbo applications, that's going to suit quite a lot of them up to quite a good power level. So that's another one that we've added. Plugs and pins also available for those. All right guys, so now you know about these awesome new products that we've added from the Bosch Motorsport range. Don't forget that there are all of the accessories that Aeroflow Performance have developed to suit these products. And you can see them all at your local distributor, quality retail outlet, or jump online at aeroflowperformance.com.